Inventory in a maintenance environment is categorized based on usage frequency, criticality, and visibility. Active inventory refers to items that are used regularly, typically once a month or more. These parts have predictable demand and are essential for daily operations, like filters, lubricants, or fasteners. Infrequently used inventory is consumed less than 10 times per year, but can still be forecasted with good historical data. These may include specialized gaskets, non-routine tools, or inspection components. Rarely used inventory consists of high-value, long lead time, or mission-critical parts that are essential in emergencies. Although they make up a large portion of SKUs, they represent a small percentage of actual usage. Despite low rotation, they must be available when needed to prevent catastrophic downtime. Hidden inventory emerges when technicians hoard parts outside the storeroom, often due to lack of trust in storeroom processes. This undermines traceability, quality control, and planning. It can also lead to part misuse or redundancy. Deadstock refers to obsolete or excess parts that have not been used for extended periods and are unlikely to be needed again. These items tie up capital, consume storage space, and inflate inventory value without adding operational value. Managing and cleaning up deadstock is critical for storeroom efficiency and cost control. Terminology is essential for effective inventory management. A bill of materials, BOM, is a comprehensive list of all the materials, parts, and components required to build or maintain an asset. It acts as a reference point for maintenance planning and inventory control. CMMS, Computerized Maintenance Management System, or EAM, Enterprise Asset Management, software is used to track maintenance work, inventory levels, reorder points, and part histories. These systems ensure that inventory data is accurate and aligned with operational needs. MRO, Maintenance, Repair, and Operations, includes all consumables and parts necessary for keeping equipment and facilities running, such as tools, lubricants, and replacement parts. The inventory turnover ratio measures how often inventory is used and replenished within a year. While high turnover is common in production inventory, MRO inventory typically has a low turnover due to infrequent part usage. Service level refers to the percentage of customer or technician demand fulfilled from existing stock. A high service level indicates good inventory availability and planning. Each part in the storeroom is tracked by a stock keeping unit SKU, a unique identifier that allows for accurate logging, location, and reporting. ABC classification or stratification categorizes inventory based on importance. A items are high value and low frequency, critical and tightly controlled. B items are moderate in both value and usage. C items are low value, high frequency, and often stocked in bulk. Just in time, JIT, inventory minimizes on-hand stock by relying on timely deliveries. While effective in manufacturing, JIT can be risky in MRO, where unplanned demand and critical uptime require buffer stock. These terms form the vocabulary of inventory control and are central to planning, auditing, and optimization. The physical layout of a storeroom has a direct impact on efficiency, accuracy, and accessibility. A well-organized layout reduces search time, minimizes errors, and improves the reliability of maintenance operations. Depending on plant size and complexity, organizations may choose a centralized storeroom for better control or a distributed layout for faster access across large facilities. High usage or fast-moving items should be positioned at the front or closest to the issue counter, while rarely used parts can be placed in more remote areas. Every bin, shelf, or storage area must be clearly labeled to reduce confusion and picking errors. Adequate lighting and cleanliness improve visibility and safety, while access control mechanisms like locked cages or badge scanners ensure that only authorized personnel can retrieve inventory. A dedicated area should exist for returns, where unused parts from completed jobs can be inspected and reshelved or quarantined as necessary. Storage equipment varies based on item size, value, and frequency of use. Shelves and bins are suitable for small, slow-moving items. Pallet racks handle heavy or bulky components. Modular drawer systems allow high-density, secure storage for small, high-value items such as specialized tools or bearings. Automated systems like horizontal and vertical carousels, or automated storage and retrieval systems, ASRS, significantly enhance retrieval speed and space utilization. Though expensive, they offer precision, inventory control, and integration with digital tracking systems. The goal of the physical setup is to make the right part accessible at the right time with minimal waste or risk. Optimizing inventory management involves using a combination of systems, strategies, and technologies to ensure parts availability while minimizing cost and waste. A CMMS plays a central role by tracking part usage, setting reorder points, and maintaining visibility of current stock levels. When integrated with maintenance planning, it helps ensure that parts are on hand before jobs are scheduled. One of the most important tools is EOQ, Economic Order Quantity, which calculates the ideal quantity to order that minimizes the total cost of inventory, balancing ordering costs with holding costs. Ordering too much increases storage costs. Ordering too little risks stockouts and emergency purchases. For accuracy and control, cycle counting replaces full inventory shutdowns with regular spot checks of a rotating selection of items. This helps maintain inventory accuracy continuously and supports financial audits. Kitting involves gathering all parts needed for a specific maintenance job and staging them in a single package or location before the work begins. This boosts technician efficiency, reduces delays, and increases wrench time. Automation tools, such as RFID, barcode scanners, and QR codes, improve the speed and accuracy of inventory transactions. They also enhance traceability and make data entry more reliable. Vendor Managed Inventory, VMI, shifts the responsibility of stock monitoring and replenishment to the supplier. This approach reduces procurement effort and ensures that commonly used parts are restocked based on actual consumption trends. In addition, items with limited shelf life, like chemicals or seals, should be tracked for expiration. Components that degrade over time in storage may require rotation, periodic lubrication, or shaft turning. Optimizing these areas ensures the storeroom is not only a cost center, but a value enabler for reliability. Measuring the performance of materials and inventory management is essential for identifying inefficiencies, improving availability, and controlling costs. One of the most basic metrics is MRO inventory value, which tracks the total value of parts and materials in stock. Monitoring this monthly or annually helps ensure working capital isn't tied up in excessive or obsolete inventory. The inventory turnover ratio indicates how frequently inventory is issued and replenished. In MRO, this ratio is typically low, often less than 2, but tracking it helps identify underused stock or opportunities to optimize reorder levels. Cycle count accuracy, or inventory variance, measures how closely recorded stock matches actual quantities during physical checks. High accuracy reflects good inventory control and discipline. Service level shows how often part requests are fulfilled directly from inventory. It directly relates to technician productivity and job readiness. Its counterpart, the stockout rate, tracks how often required parts are unavailable, leading to job delays, emergency purchases, or skipped PMs. Kit accuracy rate is vital in kitting operations and measures how often kits are complete and error-free when issued. Inaccurate kits reduce wrench time and frustrate technicians. Shrinkage rate tracks inventory loss due to theft, misplacement, damage, or clerical errors. High shrinkage signals poor controls or security. The inactive inventory percentage highlights how much of the storeroom consists of parts that haven't moved in 12 to 24 months. This identifies dead stock and justifies cleanup efforts. Additional KPIs include inventory to plant value ratio, ABC classification mix, and growth rate of SKUs or vendors. Together, these metrics form a comprehensive dashboard for storeroom performance, helping managers make data-driven decisions that balance reliability, cost, and responsiveness.